So what most people now are beginning to believe is that senescent cells are the reason that we age. Now, not to say that we're ever going to stop aging entirely, but I think we can slow it down. We can mitigate it.
Yeah, because that's the point, right?
Yeah,
All
yeah.
right.
So here's the deal.
That is the
We
point.
don't necessarily want to live forever, but we do want to, live longer and healthier. That's really, it's a health span, not just a lifespan,
So
right?
that's what we're going after. Is to
We're
live
going
healthy
at
while we live.
exactly. So what happens in our bodies is that cells are not meant, so, our normal cells divide, but they're not meant to do that forever because as the number of divisions that a cell has continues, eventually they start making mistakes, right? And you start getting things like cancer cells. So
Is that
most,
because once they've? I'm sorry, but is that because once they've divided from the alpha, that there's something that's gotten weaker?
yeah, I mean, multiple
Right.
divisions, eventually, there's just an opportunity for errors to start being made. And so typically what happens is these cells will divide for a certain number of divisions. Let's say 150. I don't know what it really is, but let's say 150. And then they are supposed to go down this programmed cell death. They're not supposed to stay alive. They're not supposed to stay in our body. They're supposed to die. Well, some cells don't do that. They actually become senescent, which means that they no longer divide, but they sit in our bodies and they secrete these really inflammatory substances. And so a lot of people now believe it is those cells and the way that they affect the surrounding cells that are responsible for aging.
What is it in the cell that gets lost? What protein or enzyme is it that gets diluted or goes away to that starts the cell to procreate? I guess if that's the
Well,
point.
I don't know if there's something that's lost per se, but you think about these cells. I mean, what they're doing is they're dividing. So one cell is making two. Each of those cells make another two
Yeah.
cells. You can see exponentially how these cells grow. And I just think if you look at the individual cell, it probably only has so many divisions in it before something goes haywire. So, but these senescent cells, so senolytics kill senescent cells. And that's important for a number of reasons, like, again, for aging. But if you give a chemotherapeutic to a person, you drive some cells into senescence. And those
Sure.
cells are probably not going to respond any longer to your chemotherapeutic. So, one of the things that I really want to do, so uh, there was a study, it wasn't our study, it wasn't, had nothing to do with Phoenix, but it came out of the University of Edinburgh just a few months ago. And what they did is they did AI, they used AI to look for senolytics, and they identified three. And it's just looking at the structure and what should be a good
Yeah.
senolytic, right? And Oleander was one of the three. And then they went on, they tested them in human cells, and they said Oleander is the best senolytic we have identified to date. So that's pretty
Did
exciting.
AI come up with a compound?
AI came up with it.
Really?
Isn't that interesting?
How
Because
about that?
we had nothing to do with this. Just so this paper got published, and we're like, yes, because we knew it was a senolytic. So my goal is to test this drug in an animal population that will be meaningful when you start looking at people.